For gradient, we looked at multiple ways of finding the gradient depending on what we actually have been given. So if we've been given a graph, then we're going to find the gradient by counting. So if our graph is as such, this is y, obviously this is x, then we know that we will look for either where it crosses the axes or count the squares. So for this one, if I say, well, there's the axes points, that's 10, and this one's 5, and the line goes through those 2 points, exactly, not like that one there, then that means that this line has a gradient by finding the rise over the run. And the rise here, of course, is negative because I'm going from left to right. Left, this point here, to right. So to get from here to this point, I must go down and then across. So I'm going down by how much? I'm going down by 10 and 5 across, which means that I have a gradient of -2. The other way to find the gradient is if I have been given 2 points. And that means I'm going to use the algebraic formula of m equals y2 minus y1 over x2 minus x1. And I'm using the change. So the change here is, of course, still the same as if I was reading up the graph, but I've got the 2 points instead. So I could be given the 2 points. If I'm doing exactly the same one, but I was given these points, I might be given point 1 as 0, 10, and point 2 might be 5, 0. And then I do the change in x and the change in y. So y2 minus, so y2 minus y1 is 0 minus 10, second point. This is my second point. This is my first point. So it's 0 minus 10 over x2 minus x1. Now my second point's x is 5, so 5 minus 0. Therefore I have -10 over 5, which means I've got -2 as my gradient. So regardless, you can either use, if you're not comfortable with this formula, feel free to plot them and then count. But if you are going to count, remember that you need to look at the scale. There are 2 special cases for gradient. The gradient can be undefined, and this happens when I have a vertical graph, and the gradient can also be 0. Which means that I have a horizontal graph. So if I draw that out, I've got, this is my x and y axes, y here, x here, and I draw, this is my horizontal graph, and this could be my vertical graph. Now, my vertical graph has a gradient of undefined. And if I had a scale on here, so for example, if this one here is 3, then that means that the equation of this line is x equals 3. It will never intersect with the y-axis. There will never be any y variables in this. Along this, all the way along this line, x is 3. Now for the blue graph, my gradient is undefined, is 0, because it's a horizontal graph. So everywhere along there, the y is going to be the same value. So if I made this value here 5, then this is a y equals 5 graph. It's never going to cross the x-axis, and it's never going to have any sort of incline, so the gradient is 0. So if I had 0 times x, right, then of course that's 0, so I have y equals 5. Same here, I have 0 times the y, or y is 0, therefore it's always going to be an x equals graph.